Deviator system task. Deviations can be used in different scenarios. Their main objective is to send flow information, or both flow and information, from one process to another one, allowing these processes to interact with each other. For example, we already know that in a process we can store information in a record of a family or in several records, or we can store information in business rules. But how can we communicate between different processes? Let's say I have process A and I need it to talk to process B, and I need process B to be able to answer back. So this is going to be done using a system task that's called Deviator system task. And basically what it's going to do is, let's say the flow is moving from one object to another one in this process A, and suddenly it reaches the Deviator system task. And this Deviator system task is going to push the flow of this process and even information data. It's going to push it into the other process. Then process B can work with the flow and the data that has been delivered to this process, and it can even send the information back or the flow back to the source process. Okay, so here we have a source process, we have a destination process, and they can communicate between each other. Actually, we could have several levels of all kinds of different processes communicating with each other. So process A could deviate to process B could deviate to process C, and so on. And then those processes could still communicate. For example, process C could communicate with process A or with process B, and so on. So this system task is going to allow us to establish this type of communication. It's also interesting because we can update the information from one process to another one. So here we have process B, and when we deviate it to process B, the flow and the information we needed are available in this process. Once we deviate from process A to process B, we're going to receive a return code. So process B is going to send us back this return code. And this return code is going to have information that's going to tell us in process A if our deviation was actually performed correctly. Here we have an example. Let's say we have a process where we have a doctor who needs to give a certain treatment to a patient. Now, this doctor picks up the patient's information, he checks all the information, he does some tests, and he gets some results. So he's got some data in this process. Sometimes this doctor can actually manage the treatment for this patient, or in other cases, in certain scenarios, maybe he cannot, he needs to send the patient to a specialist. In these cases, the specialist must continue with the treatment of this patient. So let's say, for example, the doctor checks the patient and he's got enough information, he can give the patient a treatment, so the flow goes this way. And after a week, maybe the doctor has a follow-up with this patient and then the process ends. That would be the more, let's say, the simple way in which this process could work. But then if the doctor, let's say the process starts, another different process, another scenario. It starts and the doctor, he sees that maybe this patient requires a specific treatment, so the flow goes this way, and this deviator system task triggers another process. For example, a cardiologist process or dentist process, whatever. Once it's deviated the flow and the information to one of these processes, it can wait here in this intermediate message event for the results of these treatments. So let's say the flow was sent to the dentist process. The dentist is giving the patient a certain treatment, and when it's finished, all the information and the flow is going to go back from this process, from the dentist process, back into the source process. So after a week, the doctor can follow up with the patient. So this would be an example of how we can communicate between different processes. Here we can see another example. Let's say we have all kinds of different processes where we want to launch a new product, we want to purchase raw materials, and so on. But we're actually waiting for an annual budget approval. So this process was triggered, and this one was also triggered, this one was triggered, and they all had to stop at a certain point, a certain moment in time. Why? Because they're waiting for the annual budget approval. So let's say the annual budget approval starts at this moment, it continues, and on this date suddenly, okay, we get the okay of the annual budget approval, So in this moment, we do have the budget and we can continue with these processes. Obviously, we need this process here to be able to communicate with all of these other processes in order for them to continue. So as soon as this moment occurs, it sends a signal to all of these processes that were waiting so they can continue. This is another example of how we could have one unique process affect or trigger or interact with all kinds of different processes. So in this example, we have a process that is waiting, for example, this one here. It's a new product promotion. It's waiting to do this promotion. It cannot continue because it's waiting to see if there's going to be enough budget for it or whatever. Or here, for example, we want to purchase some raw material, but we cannot continue because we're waiting for the budget. As soon as we get the budget, all of these processes can continue. Now here we can see an example of how this deviator system task would work. Let's say the doctor has an appointment with the patient and he decides we need a specific treatment for this patient. So the flow goes into this deviator system task and it triggers this second process. This second process is a totally independent process. It's a different class of process. It has nothing to do with this process here. So this second process, this one here, the one that says dentist treatment, this one could actually be managed independently. Let's say a patient comes directly to the dentist gives the patient a treatment, and then the process could end. But it could also be triggered with a deviation. So the process, this process here of the doctor sends the flow and the data to this other process. The dentist gives the patient a treatment, and then in this deviator system task, the flow is sent back to the source process. So these deviator system tasks are in charge of allowing the communication between both processes. And the events are the ones who are going to receive the information. So in order to deviate to a different process, we need to always select a start message event or an intermediate message event. For example, here, we're going to deviate to start message event. Then when the flow goes to this deviator, here we're going to deviate to an intermediate message event. Now, each process has its own panel, which can be accessed from another process. Deviator system tasks are going to transfer the necessary information from one process to another one. So when I deviate the flow with this deviator system task, I'm not only deviating the flow so this process can be triggered, but I could also be deviating data. So here I have 3 fields, comments, approved, and name. With this information, for example, in the comments it says, he has a tooth that's been damaged. It's been approved, his name is Peter. And here we also have the fields comments, approved, and name. So when the flow goes to the system task, it triggers the other process, and besides it delivers all of this information to the second process. Now the dentist gives the patient a treatment, and here we pick up some information in this process. For example, we have a signature, some notes, and when the deviator deviates from this object back to the source process, it sends not only the flow back, but it also sends information. So as we can see here, we can always deviate to start or intermediate message event. And we can do this in 2 different ways. We can do it thanks to an option when we configure the deviator system task that's called direct deviation. And this is going to allow us to deviate the flow to any message event. Doesn't matter if it's a start message event or an intermediate message event. But we could also do this with a web service. So we're also going to see how we can actually publish a start message event or an intermediate message event as a web service so other applications can communicate with these objects. So let's say we want to do a deviation via web services. Here, what we do, we'd go to the start message event, for example, or the intermediate message event settings, and we'd mark this option called web services. Once we marked it, we can enter and we can automatically generate a web service for this object. And once we've done this, any other external application or any other system that can interact via web services could actually trigger a process or unblock a process if we're triggering an intermediate message in Autoportal. So here we can see an example of a system task, of a deviator system task. And when we're going to configure the deviator system task, the first thing we have to do when we select Deviator is, do we want to deviate to another process without using a web service or through web services? I would always highly recommend when we're deviating from one process to another one in Autoportal to not use web services because it doesn't really make sense. It's much better to do it with this first option that appears here because it allows it to very easily map the fields from one process panel to the other one. So basically, we want this system task to communicate to this start message event. We don't need web services at all. Only if we want to trigger this event with an external application. So usually we don't use web services in Autoportal to communicate between processes. So as it says here, once the message event has been published with a web service, then Internet of Things, other system tasks, external programs could interact with this event. Here we can see an example of a process where we've actually stopped the flow in this intermediate event and we've published the intermediate message event so it can be triggered via web services. This means that Internet of Things, external applications, whatever could interact with this process. So here we've got a permit approval. The inspector is waiting to receive this task, but he's not going to receive it until the flow arrives, and the flow is blocked here. Now, since we're waiting for some pictures, we can wait for an external application. For example, there's a drone that needs to take pictures of the area. And once we receive those pictures via this web service, then the flow can continue. So when the drone takes the pictures, it sends it via web service to this intermediate message event. And once this has happened, the flow continues. And now the inspector can decide whether he wants to approve or not approve in this task. Once a deviation is performed via direct deviation or via web service deviation, the system is always going to give a result. So here we have the source process where we want to deviate, and we want to communicate with this destination process. So when we try to deviate, if it gives us back a return code that's a positive number, it means that the deviation was performed correctly. If I try to deviate and it gives me back a negative number, it means that the deviation was not performed correctly. So when we configure this Deviator system task, we're going to see there's an option to decide to what panel field of the source process, in what panel field do we want to store the return code. So once the flow goes through the system task, we can monitor the process and see if it gave us a negative number or a positive number. If it gave us a positive number, it's because it was able to deviate with no problems. If it gave us back a negative number, that means that we weren't able to deviate and we're going to have to check why this situation has happened. In order to know why, basically we can go to the documentation. Here we can see a copy. This is extracted from the documentation that we can find in the knowledge base. So we go to the knowledge base, we search for the documentation about Deviator system task, and there's a list with all the different codes that could appear if the deviation was not performed correctly. For example, if it's a direct deviation and it gives us a -4, it says the destination reference parameter has not been configured. So basically what it's telling us, let's say we're trying to deviate to an intermediate message event, but we don't know the exact process. So it would give us a -4. This is something we'll explain later on. If we deviated via web service, that means that we don't have permissions, so we cannot deviate. Now, how do we deviate to a EM? The first thing I want to mention is that deviating to a star message event is super easy because all we have to do when we're configuring the system task is select what start message event do I want to deviate to. And this is simple because when we deviate to start message event, all we need to do is select the start message event and the system will always generate a new process each time the deviation is performed. So let's say I'm in a source process and I deviate to start message event. What's going to happen? I'm going to start a new process. Okay, but if I want to deviate to an intermediate message event, this is a little bit more tricky because the process has already started and I could have hundreds of processes that are stopped in an intermediate message event. And I need to identify which is the exact process that I want to deviate to. So here we can see an example. Let's say I have a source process and I want to deviate to a destination process. And here I've got one of my processes that's active. It's this one with the reference PRO 8.1.15, and I want to deviate to this exact intermediate event. So in this case, I can't just select the star message event of a process. In this case, I need to know what class of process do I want to deviate to. After that, I also need to know what intermediate message do I want to deviate to, because this class of process could have 2, 3, or 100 different intermediate events. Now, once I know what class of process I want to deviate to and what object, what intermediate message I want to deviate to of the entire class of process, I also need to know the exact instance of a process that I want to deviate to. In this case, I want to deviate to the instance number 15. But how do I know this in the source process? Because I don't have this information. I need the exact instance, and I don't have this in the source process. We could actually hard code into the source process and say always deviate to this destination class of process and always deviate to this intermediate event. But I'm still missing one bit of information, and it's this bit here. So if we have all of this information in the source process, we can actually deviate to this destination. Here we can see an example of how we can deviate to an intermediate message event. So we already know this is a little bit more tricky than deviating to a start message event, because when we want to deviate to a start message event, we just say deviate to this class of process to this start message event, and that's about it. So you already have all the information. But when it comes to an EM, we have to say deviate to this class of process, deviate to this object, to this EM, and besides, deviate to this exact instance of a process. So how can one process know to what instance of a process it's supposed to deviate to? Well, here we have an example where we're going to store the reference, the key information of the destination process. We're going to store it somewhere so that the source process can look for it, it can find that information and use it in order to deviate to an intermediate message event. So in this example, let's say we're using an assignment rule, although we could also store the reference in a known family record. So let's say a process starts, and as soon as it starts, there's an upload. And this upload uploads the reference of this instance in a business rule. And it stops here in an intermediate message event. Now, if we want to trigger another process later on, it could update this information. So let's say we have a process that's launched. We update the information in the business rule, but when another process is launched, it updates the information again in the same business rule, for example, so it overrides the information of the previous one. And now we have another class of process, a totally different class of process, where we want to deviate to an EM of one of these processes. So in this class of process, we've configured it. So here there's an uploader, and this uploader, what it does, it brings the business rule to the panel of the process. Once we have this value in the panel of this process, of the source process, we can use it in the deviator to deliver or to transfer, to move the flow and the data from this source process to this exact destination intermediate event. How have we done that? We've done it using this key information, this reference here. So in this process, in the source process, we've used this information that was previously stored by the destination process in order to deviate from one process to the other one. Now, this is a scenario where we want, for example, let's say there's different processes here, and each time we launch a new process, we want the new reference to be uploaded here, so that each time there's a process of this class, we're always going to deviate to the latest process that has been triggered in this other class. So now let's say we have a new process. Let's say this was process number 1. Now we have process number 2. Process number 2 is not going to deviate to this process with the reference 14 as the previous one did. Why? Because now we have a different reference here. Now, since we have a different reference here, this new instance, instance number 2, is going to deviate to the process number 15. In the next slides, we're going to talk about different types of deviations, and we're going to see that there's multiple deviations, unique deviations. This scenario that we're explaining here only applies for unique deviations.